Good evening, everybody. Just waiting for YouTube to catch up and show me that we are definitely live. It's what we should be. Yes, there we go. All right. One moment. That's better. Right. Okay, so good evening, everybody. Welcome to episode 8 of the Porting Gitflow to Golang live streams. And I'm doing the silly thing of always clicking on my video screen rather than clicking on the presentation. Here we go. Right then. Episode 8 already. Or to put that in context, 2 weeks' time, we're a third of the way through the original budgeted time for this work. Already. So I'm feeling a bit nervous about that, but we'll see how tonight goes on that. Welcome from Wales, from the South Wales valleys. What news this week? Not a lot of news really. We're still in lockdown for another week. It'll all be reviewed again on, I think, Fridays when they'll make the announcement. It's when they normally do. So we'll find out how things are going at that point. I believe the UK Prime Minister, Boris, is currently talking live over on most places. So, yeah, come and watch me instead, rather than watch that charlatan. But yeah, in terms of news, there's not much really. Got some upcoming news. I'm not really an Apple fanboy, but I will be watching tomorrow's Apple keynote with interest. My old phone is 4 or 5 years old now, so definitely time for an upgrade. It's so old. While technically it can run the UK's COVID tracing app, sorry, England and Wales as COVID tracing app. Scotland has their own system. Unfortunately, the battery will only last about an hour or two at best, so it doesn't really work for those purposes. It's not the fault of the tracing app. The phone's just dead. So it doesn't matter what Apple announces tomorrow. Unfortunately, whether it's good or bad, I've got to buy something. So yeah, that's going to hurt. That's going to be expensive. Apple aren't going to be cutting their prices, are they? Not likely. So yeah, I don't know when they go on sale. I don't know whether next week I'll be able to tell you what I've ordered. We'll find out. That's the main news for this week. As always, whether you're watching live or you're watching this on catch up like most people do, please do leave a comment. I'd love to know who you are, where you're watching from. Leave us a bit of news about your part of the world. Love to hear about it. I'd love to hear how you're getting on as well. That would be awesome. So, what are we about tonight? There we go. Now, last week sorry, these topics were originally planned for last week. Unfortunately, we got interrupted. If you haven't watched last week's episode, GitHub quietly made a change to their platform. And by quietly, I mean you had to dig really bloody hard to find it, which we covered last week. We showed you where to go and find the announcement. And as a result of that, instead of working on the new code, last week we had to do a code review of the existing Gitflow extension and see what we needed to do about that. That's where last week's went. So the topics we're doing tonight were originally scheduled for last week. What are we going to do? Well, we're going to turn that design that we made 2 weeks ago, we're going to start turning that into some code. Or at least some prototype code is probably a more accurate statement. We're going to be creating the workspace structures. And on the back of that, we're going to be building out a list of interfaces that we want these workspaces to support. And we'll go into that in a lot more detail in a moment. And while we're at it, we're going to be keeping an eye out and starting to put together a list of operations that are going to go into our Git abstraction layer, into the GAL. And if that doesn't mean anything to you because you haven't seen 2 weeks ago, let me just fire up the iPad. Here we go. And fingers crossed. Wait, we have iPad cam. Now, you can't see me pointing at my iPad, unfortunately. And it turns out the app I'm using has a presenter mode, but you can't switch it on manually. It switches itself on automatically depending on how the video feed is connected. And sod's law, when you're taking the video feed off the iPad via the lightning cable, which is what I'm doing tonight, it doesn't activate the presentation mode. So I'm sorry about that. That's out of my control. Anyway, back to the design. So down the middle, let me just, bear with me a moment. Let me just pick a colour. So the middle is this bit here. I'm just scribbling along. This is the middle. That's our glass wall, if you like. On the left, we've got our workspaces. And that's what we're going to be focusing on tonight. The workspaces and our interfaces here. Those are the two things we want to start sketching out in code. On the right of our little glass wall, we've got our Git abstraction layer here. Excuse the terrible drawing. Now the idea is the workspaces don't talk directly to the Git binary. They don't know at all anything about the underlying Git implementation. They don't know if we're talking to a binary, and they don't know which binary we're talking to. And they don't know, the workspaces don't know even if we're talking to a substitute, like libgit or whatever it was we looked at a few weeks ago. Doesn't know. Its job is not to know. We want to abstract that away. Let me just get my diagram back into good state. There we go. So those are the things we're going to focus on tonight. I don't know until we get into it how long that's going to take. I don't know whether we can sketch out the workspaces in one go tonight, or whether we're going to need 2 weeks at it. I really have no instinct either way on that. We'll find out as we go along. We know the Git abstraction layer, this bit here, we know that's going to take several goes at it, several iterations to get right. When we did the walkthrough that led to this design 2 weeks ago, and we made a list of all the Git operations, even at that point we were kind of struggling to work out what would go in the abstraction layer and what wouldn't. So that's something we're going to have to iterate at. When we look at it, when we look at this live streams from an educational point of view, which is one of the reasons I'm doing them, iteration is one of the most common techniques I use as an industry veteran. You see, it's not, I'm going to put this iPad down, hang on a moment. Let's go to me. There we go. Right. iPad's done its thing for now. See, what we want to do, we want to make sure that when we ship code, then the code's in a good condition. But it doesn't mean the code has to be perfect straight away. There's this concept that I was taught, oh Christ, 96, 97. Fit for purpose and right first time. When we ship code and put it in the hands of other people, especially people who are going to sign it off and pay for invoices, at that point the code has to pass muster. It has to be good enough to do the job it was built for. And one way to achieve that is to spend a lot of time practicing your coding so that the code you write doesn't have to be refactored a lot. And that's a practice I used, that right first time, probably the first 15 years or so of my career, maybe longer. But towards the later part of my career, certainly the last, I'd say 8-9 years, iteration has become a tool that has worked for me better than write first time. Yes, we want to ingrain habits to reduce rework, but also writing code is not just an engineering discipline, it's also an artistic discipline. An iteration, we get something going, then we revisit it and revisit it and revisit it. Allows us to build in that artistic concept, that artistic side of it a lot more. And that allows us to discover through code designs that work for us. So that's where we're coming from with that. So what we're aiming to do tonight, there we go. What we're aiming to do tonight with our topics is we want to get our first iteration of these down. We want to get to the point where we've got something that we can say is a credible workspace structure. Might not be the right structure we ship by the time we start building releases, but we want something we can start to play with. Our list of interfaces is going to be the same, and the operations we identify for the Git abstraction layer, again, they'll be the same. Now the gal is going to be the one where we're going to need to iterate most. I think the workspaces will fall out relatively quickly as we start to build operations on top of them. But getting the balance right, what's part of a workspace and what's part of our abstraction layer, and getting the granularity right, that's going to take a bit more time and a bit more trial and error, even with 25 odd years of experience. So that's the plan for tonight. Now, I'm looking to stream for up to 2.5 hours. As always with these streams, if things have gone well and we find we've covered the topics we want to cover before then, we will cut the stream off early rather than start another task and have it hang over to next week. I find that's a more productive way to work. But we probably won't go much over 2.5 hours. Okay. So, as always, let's get coding. Let's switch to Linux Cam. And here we go. Right then. Now then, let's fire up a browser. Thank you for that, Firefox. And where I want to start tonight is I want to explain a bit more about interfaces. Depending what programming language you've come from, you may not have seen interfaces used the way Go uses them. And over the years, I've become a big fan of what Go does. I think they get this right in a way that many other languages, or more importantly, the way other languages use support for interfaces. I think Golang gets it right in a way that really promotes reuse and flexibility. Let me explain. Right. Now, the classic library to dig into is I/O, because I/O is an interface library, and it's one of the first libraries anyone writing Go plays with a lot. Now, it's a bit hard to tell from the way Go's docs are presented, so bear with me. But each of these types here is effectively an interface. And hopefully you're getting the impression that there's rather a lot of them. See what Go does. They could have easily have made an interface that represents a file or a folder, which is a kind of a classical approach to interfaces. The idea of an interface covers the entire API space, API surface, of a class. Go hasn't done that approach. Go's kind of going down the, in Swift terms, I guess it's protocols. He says, having not programmed any Swift, I've merely read about it. But Golang is really focused on behaviors. That's what it uses its interfaces for. So here, for example, we've got a reader. And the reader basically just has one function in the interface, and that's to be able to read. So any structure, because Golang doesn't have objects as such, any structure in Golang that wants to be able to plug in, say wants to say, right, I'm a reader, you can use me to read a stream of data, just implements this interface. And that's all it's got to do. Now, arguably, it has to implement several others in order to be really useful. But these small interfaces are fantastic. Because they promote the whole concept of a Lego set, small generic reusable bricks that you can plug together to the limit of your imagination, basically. That's Lego. And this is what Golang gets right. In my opinion. Code reuse I think is one of the big challenges of design. And time again, I know I've got this wrong so many times in the past. I've built and released open source packages that weren't very reusable. I've come to them sometimes years later and try to take that functionality and go, oh, I wish I had that, but not quite in the same context. I wanted to have it in a different context, and found it didn't quite fit and wasn't flexible enough. This approach, the Go approach, has solved that for me. And so far, if there are negatives, I've not found any serious negatives with it. There's going to be some. Nothing's perfect. Everything's a trade-off. Everything's about balance. But this approach works for me. I mean, because we're programming in Go, we'd be doing this anyway. We are trying to write, within the limits of my knowledge, we are trying to write idiomatic Go. That's what we're trying to do. So we would be following this structure anyway, but I wanted to highlight it because if you're not a full-time Go programmer, you either dabble in it, or you're following this live stream out of curiosity to see whether Go is the right language for you. This is something that you may find is new. It's, in my experience, it's quite rare to see other languages follow this approach. I mean, PHP is terrible for this. PHP's home of fat interfaces, unfortunately, which is not a language limitation. You don't have to write interfaces like that. Just because people use that support in PHP to create fat interfaces, you're not forced to. You can write thin interfaces. It's just people don't. The culture's not there. In Golang, we do have that culture, and that's what we're going to tap into. Anyway, enough wittering. Let's get into it. Right. Now, off camera, I did try and get to the bottom of the fun I've been having with Go and its... one moment. Golang skeleton, there we go. Oh. Sorry, VS Code has updated .gitignore to ignore the node modules folder I've got locally. There we go, that's better. So I've switched branches. And now our new Golang code should be back. Yes, it is. Excellent. So, yes, let's update the tools. Hopefully this will be the last time we update the tools. Please. be the last time. So what I've done is I'd installed Go 1.15 locally. What you do is you download a tarball for Linux that expands itself into user local Go. So I'd done that, but I'd messed up my dot files, the files that are executed when I log into as a user, in this case my demo user, and it wasn't actually putting this new version of Go early enough in my path, and that was what was causing the confusion. So that's what I fixed, and hopefully it's going to stay fixed, which would be nice. Right, so just to recap, last week, no, 3 weeks ago now, we went through and we got our skeleton all working so that we can do a compile. We're going to here. And then if we do our Gitflow command, we have our initial skeleton doing things. So that's great. Now what we need to do with this is we need to merge this back in so we can start a new feature branch. This could be entertaining. I don't know if this user has the ability to do that. So I'm going to err on the side of caution for the moment. What do I want to do about this? Let's try it. Right, actually no, I'm going to do it slightly differently. I'm going to jump onto a machine. Apologies you can't see this. It's right, my keyboard from my Mac is all the way over here today. Gitflow. But the mouse is right beside my dev laptop. Branches. And we're going to merge this in. So I'm going to raise a pull request. Again, you can't see any of this. I'm doing this on a different screen. So one moment, I'm just can't automatically merge. Ah, well, that's silly. Sorry. GitHub for some reason decided that my Golang skeleton branch, it was going to merge that into a different repo, not into the Gitflow repo that I'm merging into. So let me just do this. I'll be very quick. I'm sorry this is off camera. I need to make sure I can actually share this for the future. So right, let's raise that pull request. Come on, that'll be a pain. Just doing that. And let me merge. It's merging that in. Well, hey, there we go. So now over here on Linux CAN, now we're merged in, we should be able to tidy up. Excellent. All right. So what we've just done is off on my Mac, which is going to say you can't see that screen. I'm not sharing that screen at the minute. I've just created a pull request to merge in my Golang skeleton. And then here on Linux CAN, the screen you can see, what I've done is I ran the git hf feature finish command, which tidies up that branch. So we're now ready to continue. Workspaces, interfaces. There we go. So I'm now creating a new feature branch where we're going to work on our interfaces and our workspaces. Great. Awesome. One moment. Right. So right, by having the browser open on my Mac, I'd actually obscured the screen where I could see any likes or comments from anyone who was watching. So just sort that out. Almost need a second cam so you can see sometimes what I'm seeing. Maybe for Christmas, who knows? Maybe for Christmas. Right. So we are going to create, inside our package, a new folder called the Workspace. And we're going to put everything in. We're going to have a new, so this is, and everything's going to go in here. And that's what we're going to do. So that's our helper from last time, 3 weeks ago. That allows us to do the call throughs to Git. So we're going to start with a new file. And if you haven't seen before, what I just did there, I'll do it again slower for anyone who's not seen this before. I've got some user-defined snippets set up in VS Code for speed, specifically licenses, because there's something you stick at the top of every file. So I've got one for this project, and then I've got one for the license that we use, which is the 2-clause BSD license. So I only have to type a few letters. It triggers these. It triggers this pop-up, which then lets me choose between the two. The user-defined snippets that match. And there we go. We're up and running. Package, workspace. Now, where am I going to put my interfaces? That's a good question. I'm not 100% sure what the interfaces will look like. So I don't even know what file to create at the minute. So we go back to our operations. So when we did the live stream 2 weeks ago, when we produced the design I showed you earlier, as in the lead up to that diagram, creating that diagram, we did a review of the code and identified all of these operations that get done. So these are functions we need to implement on our workspace. That's what we need to do. And for now, we're just going to sketch out a skeleton. And we're just going to start at the top, really. So, oops. That's where I want to be. Now, I mentioned before that Golang isn't object-oriented. So what we have to do instead, let me show you. Oh, if you're absolutely brand new to Golang, go to golang.org and do the tour that they have. It's excellent. And if you're someone like me who dips into Go periodically rather than works in it all day, every day, it's great as a refresher as well. Now, where is the link to the docs? There we go, documents. Creating a module. That's the tutorial. Now, effective Go. So let me explain. I'm sorry, I'm blasting through this without actually explaining. So I'm on the documents page of golang.org, which is all the documentation. And one of the things they have partway down here is called effective Go. And that is pretty much the go-to guide for writing idiomatic Go. So much so, I can't remember what the topic was. I was digging through the Golang repo looking for, or it could have been the mailing list, looking for a solution to a problem I had. And even the creators of Golang will follow this document over their own desires and own personal preferences. You don't get much more idiomatic than that. So well worth looking into this. So I am digging in here, looking for I was looking for something on structs because you'd think it'd be in here, but it's not. Language specification would have what I want, but it's a bit, I found it a bit dense in the past. I've not looked for a while. Maybe it's improved. So I'm just going to do a Google search here, see if I can find something better to show you. Well, go by example. Let's try this. This is a handy site. If you've programmed in Python, yeah, this is a good analogy. If you've programmed in Python, structs in some ways are similar to Python objects, because if we go through to the next page, you define the methods. And you know, in Python you pass self in to actually reference the data that you're modifying, the object. You get something here. They call it a receiver type. And receiver types can be pointers or they can be values. Pointers are typically used for when you want to modify data, and values for receiver types are typically used to guarantee read-only behavior, immutability if you like. I say typically. You'll see a lot of old school developers who grew up in times before modern computers who will use pointers for efficiency because it avoids a memory copy in theory. Although I think the Go compiler these days may be a little bit better at that, at optimizing that away. I'm not sure. Something to play with. But anyway, the main point I wanted to show you is how instead of objects, we've got a structure that holds data. We define methods. Yeah. I guess this layout's a bit old school. See how it's highlighting the left instead of using columns to keep the two apart. But we've got methods, and what makes them a method is the fact that they take a receiver of some type, and then we can initiate them like that. That's one way to initiate them. There are others, if memory serves. That's how we allocate memory to start off with them. So a little bit different to objects. So this is what we're going to be sketching out tonight. And we're going to start off with an empty struct. I'm deliberately leaving a blank line because I don't know yet what I'm going to put into it. And we need some documentation. And this is Golang, so I don't need to do it that way. So Workspace. Now this is an interesting point. So one reason I write documentation is it's my way of explaining what I'm doing to myself. In a normal office environment, if anyone can remember what those days were like, you would normally explain your work to another person. And sometimes the simple act of explaining what you're doing can make you go, hang on a moment, that's not necessarily a great idea. And that's what I've just had here, because we've called this Workspace. But how much of it's Workspace and how much of it is repository? Because I was going to say, Workspace represents a Git repo. And then immediately looking at that, I'm going, but that's daft. Why wouldn't a repo represent a Git repo? So it's possible we've actually got two structures we want to define. It's possible we've got two. So that's what I'm going to do. I'm going to make space for two. And repo represents a Git repo. And then Workspace represents a working environment based on the checkout of a Git repo. Now in OO terms, a workspace if we were in a classical OO language, a workspace would almost certainly be an extension. It would extend a repo class. It would almost certainly do that. We don't have inheritance in Go. If I go back to Go by example, and we dig through this, here are our interfaces, which we'll deal with another time. And then we go through to errors. So if we do a search for Golang Inheritance, what you'll see we've got is composition, embedding, and interfaces. And of course, Google being Google, front page. Where's Golang on there? Why isn't the Golang site on the front page? Why doesn't Google know that Golang.org is the canonical reference? It's the big flaw in Google, really. So let's try this website, Golang Docs. Let's see if it gives me something good I can show you. Okay, so it's what it's showing here. It's got two structs, a polygon and a triangle. And triangle embeds polygon. Aggregation, if you like. And then when we define a triangle, we also when we initiate a triangle, sorry, we also initiate the polygon inside it. That's how that works. So we're going to go with that for now. And we're going to say a workspace embeds a repo. And we'll try and work out which methods go on the repo and which go on the workspace. Fortunately, the division between the two is pretty clear. The repo is anything that touches the data Git manages, and the workspace touches anything outside of Git, like local files. So, for example, if we go back to our list here, local branches, remote branches, all tags. These are all things that are repo operations. So we're going to stick them here. We are going to call this local branches. And we're just going to leave it empty. And we've got remote branches. And there's nothing sophisticated about what I'm doing. There's nothing clever here. I'm literally duplicating all the functionality we've had beforehand, or making space for it. At this early stage, I don't know what shape I want to change it to, so I'm not going to worry about that for now. We'll tackle that in a later iteration. So current branch, I'm going to say that's that current branch is a workspace operation. And I won't always get these divisions right, but that's where I'm going to start with. So let's just split this out. It will go a little quicker. View, editor layout, split right. We're a little limited for horizontal space here on this laptop screen. But normally I'd have VS Code open on a bigger monitor with more space than this. So where are we up to? Current branch is clean working tree. That is absolutely a workspace operation. I mean, that's not even in doubt. I say that, but it is in doubt. I'll explain why in a moment. Right then, so we want func r star repo local branch exists. Hang on, can't type tonight. That's where we're up to. And then we want remote branch exists. And then we just want branch exists. And at this stage, I am literally just copying across the names. It's literally all I'm doing. Excuse me. At this stage, I don't care what the parameters should be or what the return value should be. We're trying to find the shape of it. So this is a technique that you could call decomposition, if you like. We're taking a larger concept, which in this case is the workspace, and we're breaking it down into its smaller constituents, which is the repo and the operations that both need to support, and the division between them. So it's a technique here is called decomposition. My uncle at Melvin, who I doubt will ever get to see this, but hello Melvin if you ever do, he taught me this back in the early 80s. Let's switch camera for this one. That's better. So in the early 80s, when things like a phone in the home was rare, TVs still ran on vacuum tubes rather than circuit boards, and home computers were just starting to appear. My uncle Melvin bought a ZX Spectrum, and he bought it actually to help him in his day job. He either was or wanted to be the manager of a warehouse. I can't remember if he actually was when he started. I was too young to remember this. And so he bought this ZX Spectrum, and he taught himself how to program so he could build an inventory system for the warehouse he worked at. And it either helped him in his job as a warehouse manager, or it helped him get the job. I can't remember which. Maybe Melvin, if he ever watches this, will leave a comment. And that's how I first started programming. Was going around to Uncle Melvin's house and using his Spectrum when he wasn't using it. And yeah, when you're at 9-10 years old, you learn quick, and you often learn quicker than adults around you, partly because of your age and partly because you've got more free time on your hands. So it didn't take very long before my programming skills were better than Melvin's. And I started to hit a wall very quickly at that point because I couldn't progress because I had no one to learn from. There was no internet back then in the UK. There would have been dial-up bulletin boards, I suppose, but I don't think we had a modem. I don't remember one. Everything, you got software by literally buying a magazine, and the magazine had lots of hexadecimal codes in them, and you wrote little programs that would then help you type in all of those codes into the computer, called peek and poke, after the two main commands for manipulating memory on the ZX Spectrum, the peek command and the poke command. It's going back a long time. So Uncle Melvin taught me the technique of decomposition, because he couldn't teach me how to continue learning to program, but he told me to start looking at larger things and say, right, how do you break it up into smaller chunks? What's this bit over here? What's that bit over there? How could that possibly be represented? How do you take a bigger problem and break it down into lots of smaller problems? That's the first part of decomposition. The second part is doing it over and over and over until you learn to decompose things in a way that will still fit back together when you're done with it. So I learned that technique, no later than 1984 it would have been, which is that many years ago, 30 odd years ago. And it's a great technique for writing software. Front end stuff, I can't design for toffee, I really can't. But I can still build a working front end if I have to, by saying, right, I want a nav bar, I want a sidebar, I want information panels. And so all of a sudden I'm not building a front end, I'm building a nav bar, I'm building a sidebar, I'm building information bars. And it makes the bigger problem into a smaller problem. And that's exactly the same technique I'm using here tonight. And the other thing I'll say while I get back to the code, there we go. Got to put the little side camera on, which is over there for me. The other thing I will say is I'm actually a qualified software engineer, which is quite rare these days. I'm very used to being the only person in the room who's actually qualified to do this job. It doesn't mean other people shouldn't be allowed to do this job. It doesn't mean they're not worthy. It's not like that at all. But I actually have formal training. Nowhere in my formal training do I remember being taught decomposition as a technique for writing software. More's the pity. I think people should be. So back to the code after that little spiel. Here's a good question. Ping the remote to see where it is. Is that a repository action? Is it a workspace action? Where does it go? I mean, this is all Git functionality anyway. But does it, philosophically, where does it fit? Often with these things, there's no one right answer. And it's easy enough to move it if we need to. So for now, I'm going to stick it in the workspace because that, honestly, it's because it feels right. It's not an intellectual decision, this one. It's definitely an emotional decision. If you build up your inner observer, your self-observation muscle, if you like, so that you learn to monitor what you're doing as you work. It's a process called internalization, which is something most martial artists who watch this will be very familiar with. And eventually, that observer starts talking back to you. But it's not a little voice in your head chattering away. It actually talks to you via emotion. That's what it does. And you learn to feel out solutions to problems by your training your inner observer. And it talks to you back to you via your emotions. And in this case, my inner observer is saying to me, perhaps this is a workspace operation. Perhaps. It's not sure. That's for certain. So I'm going to put it in the workspace for now. Now, our comparing branches, which is let me highlight this. I should highlight as I'm going down so you can see where I'm working. So, our repo, compare branches is definitely a repo operation. Is branch merged into is definitely a repo operation. Getting the value of a git config. I'm going to argue, perhaps wrongly, that that is a workspace operation. And I'm sure those of you watching live and anyone watching on catch up are probably glancing up from whatever you're actually doing at the same time while you're listening to this and going, hang on a moment, config get branch, shouldn't that be an operation on the config? And you're absolutely right, it should, but we haven't introduced a config structure at this time. We haven't actually introduced one. So that's going to be our second iteration, is where we identify how to decompose what's turning out to be two bloody large structures already. We're going to break those down in a moment, but first of all we want to start off by having an initial home for everything, and then we can move things around. That's what we want to do. So it might look like I'm doing a lot of unnecessary work here. And if you feel that way, there's nothing wrong with that. There's nothing wrong with that feeling at all. This is how I work. It has served me in excellent stead. One advantage of this technique of sketching things out and then iterating, especially quickly, is, in theory at least, it avoids a mental problem called fixation, where we go from problem to solution in one superhuman leap and miss out on all the other possibilities. Fixation. And that's not to say fixation can't actually get you to a workable solution straight away. It absolutely can. At the end of the day, it's how most people work and operate. But by doing things slice by slice and building in lots of iteration, people who work with me in the day job will tell you, the version of code I'll ship will often be version 10 of, even version 15 of it. Rapid iteration. As long as you can iterate rapidly, you can get away with it. If iteration is a technique that's very slow to you, that's difficult. That's difficult because time is always an essence. Right. So now we're starting to get down to some of these Hubflow operations. And for now, I am sticking them on the workspace. And I'm not changing any of the names, any of the terminology yet. That's to come. We are literally right now trying to find a home for everything. That's what we're trying to do. It is initialized. Yes, next. So, is feature branch, is the given branch actually a feature branch? That's not a workspace operation. It's not a repo operation. It's a Hubflow operation. So at this point, it's becoming, excuse me, my hands are really dry today. Mondays are a day where we go out and do the weekly shop and things, and the all the hand sanitizer and all the soap when you get home and you wash your hands, etc. Absolutely dried my hands out, and it drives me nuts. I'm a very tactile person, and yeah, dry hands are horrible to me. So anyway, I'm going to create a new package for now, which I'm going to call Hubflow, just because I need somewhere for it to live. And I'm literally doing this just because it needs a home. It almost certainly is not going to end up looking like this. But I need space to work. It's always about space. So it means we can grab all of these, dump them in here. So what I've done is I've taken some of the operations that are utterly Hubflow operations, like is the master configured, is the develop configured, are the prefix configured, and I'm just dumping them as methods on the Hubflow struct for tonight, so that they're out of the way. We've got load settings. We've got Hubflow change branch. I'm going to put it as an operation on Hubflow for now. I'm hesitating a little. Then we've got our little branch stack. Excuse me. Do we need to do that? I'm hesitating a little bit. When we took the shellcode apart, the bash script apart several weeks ago now, There was some code there where we were taking branches, and we were maintaining a little push-pull stack internally, so we could keep track of where we were through the operations. Now we're working in a more powerful programming language with much better variable and scope management. I'm not sure we need those, so I'm going to leave those out for now. I'm going to leave those out. And what we're going to do is we're going to move on to the remote merge helper. It would help if I typed in the right window pane. Remote merge helper. And then we are going to go over here to the local merge helper. Then we've got fetch latest changes from origin. I'm going to stick that in here for now. Changes from origin. That is an operation that almost certainly won't survive. If nothing else, because the where you're fetching from and where you're pushing to, which is the next item here, push latest changes to origin, they're going to be parameterized. But we'll fix those later on. We're not trying to get the world right here. We're trying to find our shapes. Or rather, more accurately, we're trying to find the shapes that we want. So I'm hesitating because of course many of the things we're doing here, this Hubflow this Hubflow struct may not even survive at all. Because many of these here are actually CQRS type operations that we're going to want to move away from. I missed one. But we're not jumping straight to a CQRS architecture. We're going to find the shape and then we're going to morph it with an iteration. It's what we're going to do. And it'll be fine. So set up tracking branch for a given branch. That's a workspace operation. Right, resolve name prefix. That's a repo operation. Require get repo. That is currently a Hubflow operation. That's an example of a guard or a guarantee. So we'll find a home for those. We're going to find a home for most of these later on. And again, yeah, require base is on develop. That's something else that we're going to move out of here. Right, require remote available. Okay. Yeah. When in doubt, I'm sticking these as these higher order functions, which is a term that's used very differently in computing. Sorry. These functions that are closer to business logic, I'm sticking them on the Hubflow struct for now, so we know where to find them. Require Hubflow initialized. There we go. Require clean working tree. Anything to do with the working tree is part of the workspace, in theory. Require local branch is part of the repo, again in theory. Then we've got require remote branch is over here. These are probably not going to stay here either. Require branch. We've got to make sure a branch doesn't exist. Require absent. Require branch absent is next. And then we've got to do the same thing with tags. Require tag absent. And then we require 2 branches are equal. Right then. So at this point, we've got through a lot of our operations already, just by sketching them out. I mean, even if this code compiles, it's not even bloody worth compiling at this stage. That's not our intention. Our intention is to start to discover shapes and flush them out. That's what we're trying to do here. So we've got additional git commands scattered throughout the code. Creating branches and setting the backing track at the same time. I've got a neat trick to show you about that one. But before we get into these, because these are nearly all low-level items, what I'm doing, I'm now firing up the iPad. I'm going back to my diagram. Should be here. Right. So what I'm looking at with the diagram is, where's my pencil gone? I'm thinking about this lot here. We've got the CQRS style and the Hubflow common. As they're going to be actions, queries, guards, and guarantees. Is how we're going to break those up. And they're going to use the interfaces that we define. They're going to consume and work on interfaces, and we're going to implement those interfaces as workspaces. That's the plan. And as part of this, oh come on, there we go. Shrink that down just a little bit. As part of this, only workspaces are allowed to talk to our Git abstraction layer. But our Git abstraction layer, we don't yet know what it looks like. We don't yet know. So we've got to make sure that all of our stuff over here, our CQRS style business logic, is only interacting with workspaces, and which in our case, a workspace embeds a repo. That's what we're going to do. Right. It's always useful to keep going back and referring to the original plan. Plans have to change. Plans very rarely make it all the way through to live, intact. Nature of the beast. But we have to start somewhere. And am I yet ready to go back to 1? I'm probably not. You've got to keep this as 2 at the minute. Right, that's my... I'll just move that to one side, I think, for now. Of course. Package, Hubflow. And you are still not happy. Okay, so these yellow lines are the linter, and many of them at the minute are saying that in Go we have to provide comments above them, otherwise we shouldn't be exporting them, which is fine. So that's what those are. And weirdly, we're not getting the same error, linting error, in here in the repo file, nor are we getting them in the workspace. It really should be complaining about all of them, but it's not. So let's just put something in here just to get rid of all the yellow. You see, that only got rid of one. So yeah, the tooling can be a little inconsistent. Not the end of the world. I'm a great believer that you really should treat all linting warnings as errors anyway. I'm a bit old school on that. Somewhere there's probably a mailing list archive with me arguing with Richard Stallman of the Free Software Foundation fame over this. When I was doing C on a very regular basis in the mid-90s, very much came to the opinion that you treated all warnings as errors. Something that even today is controversial. And I'm pretty certain I had an argument with Stallman about that back then. It'd be on a mailing list archive somewhere. Right, what do I want to do? Right now we are nowhere near at finding our interface. Absolutely nowhere on that, which is okay. I think what I want to do is these additional git commands, I want to make them repo operations. First and foremost. That's what I want to do. Yep, that feels right. So we've just done create branch, push ref to origin, delete local branch, delete remote branch, so repo, diff branches is next. Funcast star repo, find merge base, check out branch. Excuse me. Star repo, rebase branch. I'm being very specific here, probably too specific. Rename branch, but star repo, pull and rebase. So so get commit hash for branch. I'm going to do next. Is branch pointing at tag. Star repo get short commit hash r star repo. Okay, is branch merged into? We've already got one of those, so that's a duplicate, but that's the low level code doing it. Is create tag. Oops, done square brackets by accident there instead of curly braces. Star repo, we've got create tag, push tags. Are we in a Git directory or not? That's high level, I'm going to leave that out. Get the list of configured remotes. We've said remotes belong to workspaces. I think we're going to be moving some stuff off repo over to workspaces in a moment. I've just had an idea. Okay, so create head is that, and then we've got do a prune, right, and now repo is highlighting all the things, so the lint is now highlighting all the things we've not commented on. And if I save workspace, it's now doing that as well. So there we go. Now the tools are behaving consistently. I can live with that. So we've got through the workspace we've got the repo embedded in the workspace. Now what I'm thinking of is being able to separate out local and remote would be awesome. We almost want local and remote to be two properties of the workspace. Or you call a function, you get that back. And that is where we'll start to see our repo concept starting to disappear a bit. That's what I'm thinking of in my head. See, instead of ping remote, yeah, let's use this as an working example. So I've just highlighted there on the screen. And we've got this method on the workspace struct called ping remote. What if instead we could do something like this? So we'd have code that looks something like, and this is right. So func example. This is very much just me sketching things out here. So we want to create a workspace. There we go. So w equals workspace. We're going to ignore initializing the repo for now. And then what if we could say remote, we could say w.remote.ping. Wouldn't that be better? Wouldn't that be better? And it would be even better if that took a parameter, like origin. Obviously, we'd turn that into a variable. That strikes me as a better user interface, a better API rather, than where I was going before. I like the look of that. So the repo concept that I've split out will disappear, and it'll be broken up between local and remote instead. On all the operations that we've got for the repo, we'll probably move back onto Workspace in some form or other. So, you'd have, you've got w.get configured remotes. That now makes a lot more sense. For example, whether or not you can have a tracking branch. That would be part of the local one, so w.local.set tracking branch, for example. There's a bit more to it than that, but you get the idea. We're starting to find our shape. So what we're going to do is we're going to roll with this and see where it takes us. I'm deliberately not committing anything here. I think repo isn't going to survive as a concept, so I'm not worried about committing the code here. So we're going to want remote.go, and we're going to want local.go. Repo might survive. I may be being a bit hasty there by saying it won't survive. Package Workspace. So we want type local, and we'll create an empty struct. And then over here, license Gitflow, license to BSD, package Workspace again. And again, we're going to go type remote struct. The other thing we're doing here, though it's probably not obvious yet, is we're starting to make space for our interfaces that we're gonna have. Save that so it doesn't complain. Right, so now if we go back to our repo, and I'm going to move this to the right hand side of my screen. So now what I'm looking to do is I'm looking to the repo shape that I carved out. I'm now looking to redistribute that across Workspace, remote and local. So instead of local branches on local, we are just going to have get branches. And it doesn't matter what it returns. And on remote, we're just going to have it on the remote. Again, it's going to be get branches. We don't care. Sorry, with remote branches, we're looking for branches on a specific remote. We're not looking for branches across all remotes. So we're okay with this. of having a get branches operation on a specific remote. We're okay with that. It's something to keep in mind as we work, you see. So local branches, remote branches, there we go. All branches, I'm going to leave that in repo for now rather than move it over to Workspace. I'm not deleting repo entirely yet. All tags, I'm going to leave that because that's local tags and remote tags. But what we probably want to do, we probably want to reprogram that. To be able to get the tags from the remote. And we want to get the tags from local. We want to rebuild it to get both of those. And then it will call both of those. Now, is headless is definitely a local operation. Or is it? We're going to put it in local for now and leave it there. And then local branch exists. Well, that clearly is now broken up. Just say branch exists. And then we go over to remote and we do the same there. So that's good. And then we've got branch exists as a general operation, which we're going to leave. We're going to leave alone. Then we've got tag exists. So you should be getting the drill by now. We're taking these operations and we're breaking them down onto whether they work locally or remotely. There we go. Compare branches. That has to stay in the repo because that might be comparing across local and remote. Is branch merged into? That may have to work across both. But for now, I'm going to assume we can split it up. This could be a mistake. No two ways about that. Let's make that as a remote. We'll have to see. Is branch merged into? List branches of type. Once again, we're going to make that an operation on each of these. I'm going to make that a local operation, and then we're going to make it a remote operation. Resolve name prefix. Sorry, I'm hesitating for a moment. List branches of type is a repo operation, I think. I think we want local and remote to be a bit more low level than that. So I'm going to take that out. Resolve name prefix I'm going to leave out for now. Require local branch, well that becomes require branch. And we'll do that on both. And the full knowledge that that is almost certainly, all these requirements are almost certainly going to move into our CQRS style business logic. But we'll leave them there for now. Require branch absent, require tag absent, require branch is equal. Then we get down to our get operations, create branch. I'm adding it to remote. I don't even know if we can do that directly on a remote. We always If you think about it, when you use Git, we always create it locally and then push it up to the remote to create it. So we may not be able to actually do that on the remote, but we'll leave it there for now. Push ref to origin we'll leave on the repo. Delete to local branch becomes delete branch. Becomes delete branch. And we definitely want to delete remote branch. That's definitely an operation we need. So those can go. Diff branches can work between origins, between local and remotes, so we leave that alone. Same with find merge brace. Checkout branch. You can check out a remote branch, it has to be said. So it's got to be on both. Whether we need it for both is a different matter. But for now, we'll implement it for both. Rebase is a local operation. At least it is for the minute. Renaming a branch. Can you bear with me? Can you rename a remote branch? We can fake it. We can fake it. So he says, assuming that random page Google threw at me is reliable. We can rename a remote branch, and in theory, so we can fake it. So there's local again. So func l star local rename branch. Pull and rebase. And we're going to make that a local operation. Then we've got get commit hash for branch. And we can do that on remote branches as well. Excuse me. Is branch pointing at tag? I believe we can do that on both types of branches. So let's do that. And again, we'll grab that for remote as well. Get short commit hash. That works both on local and remote, I'm pretty certain. I think we're going to use it locally. He says desperately trying to remember where we actually use it. We will find it. Then we've got create tag. That's a local operation. We create tags and push them. Take that out. We should actually be pruning these a bit more. So checkout branch, rebase branch, rename branch we can take out, pull and rebase. I've said that is a local operation. Attempt to leave it there for now. Get commit hash for branch. Is branch pointing at tag? Get short commit hash. Pull. Right, so we've got create head. So sorry, push tags I'm leaving as a repo operation. Create head is a local operation. And then prune is a repo operation. So we're starting to split things up. We are definitely starting to split things up. Now, some of these operations need to be moved into our CQRS architecture as time goes on. That's what they need to do. But for now, we've got a structure. So we've still got things in quite a lot of operations that operate on the repo level. And that's one reason for that, is to stop Workspace.go getting stupidly large. Let's just do that, stop it complaining. Thank you. So there's definitely work to do there. But the idea feels sort of okay. It's sort of okay. The main reason I'm hesitating is that Git abstraction layer. That's our challenge. That's the piece of architecture that, whilst it's important for us to be able to do, it also directly affects the design of everything else. So right now, I'm kind of proceeding by sketching out this these workspaces. I'm proceeding as if that Git abstraction layer is a problem for another day. I'm not sure about that. I'm not sure about it. But, you know, I mean, the operations our workspace supports doesn't look too bad. It's not terrible. It's not terrible at all. The question then is, does Workspace actually survive? What's the difference between Workspace and Repo now? At some point, we're going to have to start building these, building out our business logic, and that's when we'll start to flush out some more of our design. When we actually stress what we've built by using it. But we're not there yet. See, one of the reasons I'm hesitating is because I'm just thinking things through in my head. One of the things about these structures is the lack of extensibility. Lean structures and large. Let me take a step back. So, if we take local as an example. Locals, the operations local can do is always going to be limited to the methods we define. Not just, and it doesn't just limit us in the Gitflow extension. It limits anybody who decides to pull our packages in to build some other funky tools as well. So you're better off making your structures as thin and as dumb as possible, and turning as many of these into functions. But instead of taking a receiver type, excuse me, what they do is they actually take a parameter instead. You're better off doing that as an approach, because then people can write whatever the hell they want. It's far better. So I'm just trying to decide what I want to do about that. That's what I'm trying to decide what to do. There's always the allure of the object-oriented style approach with lots of methods on a type. There's always that allure. Doesn't mean it's a good one. Now that does bring us back to interfaces. One of the downsides of an interface is it describes methods of structures in Golang, just like it describes methods on classes in classical languages, in more classical OO languages. So if we want to have a pool of interfaces that our business logic consumes, that forces us to have some methods on our workspaces. Doesn't mean it's these methods. Does not mean it's these methods. Just thinking about our options. I mean, something we're seeing here, if I pull remote up as well, checkout branch, rename branch, that implies there's some sort of branch structure that we want. So maybe let's flip this round. What we're going to do is we are going to start to populate Workspace, and we're going to start, what we're going to start to do, we're going to start to decompose, so decomposition again. We're going to start to take local and remote apart and turn them into standalone functions. That's what we're going to start to do. Yes, that feels good. I'm just trying to decide what to do. We're going to do the obvious ones first. So we're going to do new file, guarantee require branch. I'll explain these file name prefixes in a, well, actually I won't explain them. They'll become obvious as we work through this, and then I'll be able to talk about it afterwards. So we've got a func called require branch, and it's going to take a concept we haven't come up with yet. So we're going to want R of type repo, and we're going to want branch name, I can't type string. And we don't use colons in Golang. So we've got require branch. This is now a standalone function. So we're going to take this out of our remote. We've got create branch. So new file. So we're going to stick this out here now. Package workspace. Func create branch. This again is going to take a repo, and it's going to take a branch name. And once again, we don't have colons separating these out. That's TypeScript. And our braces have to be on the same line in order to get rid of the linter error. There we go. Right. Let me make this a bit easier to read by shrinking these sidebars down. There we go. So that gives us create branch. So we can take that out of our remote, and we'll prune our local in a moment. Then we've got delete branch. You can see where this is going. Action. Delete branch.go. I'm sorry, I shouldn't use phrases like you can see where this is going. That's a bit silly of me. Func. Delete branch. Takes a repo. Takes a branch name. This time I didn't put the colon in. Get in there. So we've got delete branch. And then we've got action. Checkout branch. I'm not pretending for a moment that I've got the parameter list right for all of these. These are all placeholders. And I put the colon in this time. It's TypeScript. Because there's no package, that's why you're complaining. It's taken the semicolon off for me. Right. Yeah, unfortunately, well, I say unfortunately, TypeScript is a language I have utterly fallen in love with. Concerns about the runtime engine aside, as a language, it's probably the language I've been looking for the last 5 to 7 years. It really is. But this is a live stream about Go, not about TypeScript. So, and I am totally turned into a TypeScript fanboy, for which I can only apologise. Package, workspace, so func, rename branch, and we want a repo, and we want a branch name. And we're going to give that a type string for today. Cool. Let's just prune these. So now we're starting to make our remote look very, very thin indeed. So let's grab some of the others. Branch exists. Let's do that one. So this is the type query. So there we go. So branch exists is now an operation. Tag exists. That can be our next operation. Our next query. I feel like I should have like a slide deck to explain this architecture a bit more. The actual CQRS approach I'm taking. But I'm deliberately trying to show it through code at this time round. There we go. So tag exists is done. Let's keep pruning these down. And all of a sudden our remote is looking really thin. I'm going to leave that there for the moment. I don't want to prune the rest of them yet. Let's go over to local. So, is headless. Well, first of all, branch exists. We've done that. And tag exists we've done, so we can delete those. Require branch, we've done that. Create branch, we've done. Delete branch, we've done. Checkout branch, we've done. Rebase branch we haven't, so let's create a new file. and that's another action. So this is rebase branch. Let me just fix that repo. There we go, it's got to be a capital. So we've got rebase branch is now done. Rename branch already exists. Create tag we haven't yet done, so let's grab that. So this is our package workspace, func, create tag. There we go. Let's create tag. Done, we can get rid of that. Create head needs doing. So all of a sudden, that rather large list is starting to shrink down. Excuse me. All this code that we were potentially going to have to create and duplicate, or create equivalent functionality in local and remote, a lot of it is now hidden away in reusable code. What we hope, sorry, let me correct myself there. What we hope is reusable code. Until we actually pad all these out, it's just fingers crossed for now. This design could easily have problems with it. Let's not pretend otherwise. So, what do I want to do with the rest of local and remote? So here's the interesting thing. I don't yet know for certain, but it feels to me that local and remote are actually going to be the types exported by our Git abstraction layer, or GAL as we call it. It's starting to feel that way. That they're going to be the operations that live on the other side of our glass wall in our architecture diagram. That's what it feels like at the minute. Whether or not that's the right structure, I'm not sure. But it's starting to feel that way. It's starting to feel that way. Which means our workspace is starting to get really small. Go back to Linux cam. And let's go back to our workspace for the moment. I mean, is clean working tree? That's a query. So let's do something about that. Is clean working tree.go. Is clean working tree. That takes a workspace and it returns a bool or an error. Which of course I'm now being told we haven't implemented it. We'll deal with that later. So current branch becomes an operation, becomes a query, sorry. Query get current branch dot go. And again, we put our licenses in, we put our package name in, get current branch. And for now, we're going to make this take a workspace rather than a repo. And that's going to return a string. There we go. Sorry, I should fix that because there we go. It was red, it was annoying me. It was red in the sidebar down here. The current branch goes away. Ping remote. And then we've got configs, we've got set tracking branch. So let's do that. Action set tracking branch dot go. Package workspace func set tracking branch. And again, we want a repo. I want a branch name. And then we can take that away from our workspace. Require clean working tree. That's a guarantee. Put that in our workspace. Require clean working tree. You're going to take a workspace for me. And we're going to return a bool and an error. Except we're not. No, this is not a workspace thing. This is a Hubflow action. So let's package Hubflow. Because if we want this to crap out, for lack of a better phrase, will it import workspace for me? Nope, it won't. And to import, bear a moment. Right then, okay, that's the syntax. So what I did there was I grabbed an existing file that I know works in order to look at an existing Golang file that I know works in order to look at the syntax of the import statement. But of course it doesn't tell me the import for this com data sift Gitflow. Slash workspace. Right, so I'm trying to remember how you import from a package, from a remote package like this. And we had this the other day. I look at feature cancel. There we go. That's the kind of syntax we're looking for. Gitflow / package / workspace, and then this import becomes workspace. There we go. Sorted. So what happened there is I don't keep all the syntax up in my head. During the week, I programming 3 somewhat different programming languages, as in a heavy amount of code: TypeScript, PHP, and Golang on Monday nights. And it's not about memorizing all of the syntax, all of the standard library. It's about knowing how to quickly find what you're looking for. Because half the problem with Google when you're searching for solutions for a programming problem is you don't know what to search for to find an answer that's appropriate. You've also got the problem of how do you sort of look at those answers and determine which ones are worth implementing for your circumstances and which ones aren't. But you're not even going to get to those answers if you don't know what to search for. And so because Go is currently the programming language I use the least of the three, it's the one I have to do the most looking up for. And to do that, what I do is I go and find existing code I've written in the past that I know works, and just read it to remind myself of those little things. In this case, what I was doing was I needed to make sure that the workspace parameter here, the type, was imported correctly. And just to stop it complaining, there's a guarantee. It logs a fatal error. The working tree has files that are currently staged or are currently untracked. There we go. I had the comment there just to keep the linter happy. But that is a Hubflow operation, and we've said it logs a fatal error. So we've got some work to do there on that later on. Let's go back to our workspace. So require working tree is no longer a workspace operation. Get configured remotes kind of is. We'll come back to our example code in a bit. Excuse me. Now that's interesting. All I did was remove this example function from, I'm pointing at my laptop, from workspace.go. And did you see how the sidebar colors all changed? Files that were green or yellow before have now turned red. It's frustrating when tools do work like that. And why are you complaining? Undefined repo. Okay, it's absolutely right. It should be complaining about that. But I'm not going to fix them tonight. This code isn't for committing tonight. We're experimenting. That's what we're doing. So what operations have we got left? We've got these config operations. And we're going to make those workspace operations. Yes, we are. Action. Set config. I'm going to leave that alone for now. I'm not entirely sure what that should look like. Ping remote is definitely an operation. Action ping remote.go. Let's put our license in. And then we go, make sure we've got a package in, and then we've got func ping remote. And this is going to be a remote. Which should go red because I haven't actually imported remote. But it's all part of the same workspace, so I shouldn't need to import it. Which is interesting. We'll worry about that another time. So ping remote's gone. Left these configs in for now. And then get configured remotes. Well, I think that just becomes a query of get remotes. I don't know what it's going to return, but we do need a workspace. There we go. So we're going to consume a workspace and return the list of remotes. And it'll be an array of repos, I'm sure. Right. So we have absolutely gone at this now. And our workspace, which had goodness knows how many operations in, it's only got 2 left at the minute, which is our config get branch and our config set branch, because I'm hesitating about what I should do with those. And instead, what we've done out here, let me expand this over here. What we've started to do is we've started to build out our language. We've got actions. These are things. These are operations we're going to do. We've got our one guarantee in the workspace package, which is that we require a branch to exist. I pretty much want, because Golang doesn't have exceptions, I pretty much want guarantees to live elsewhere. See, in languages with more classical error handling, an exception forces you to unwind the programming stack. So it can be a great tool for preventing error conditions, error states from propagating. And there's a lot of people who don't quite get this because they just think it's just throw an error. But the thing with an exception is it halts the normal execution of your code. It terminates the happy path. That's its primary purpose, is to terminate the happy path at the earliest opportunity. Very, very useful. Now we can't do that in Go. So normally a guarantee would throw an exception, so we wouldn't have to check the return value for an error. That's not the Go way. So we have to adapt. And the way we adapt is we move the guarantees out to the code where the user interface is. We can still have them, but instead of throwing exceptions, all we can do is bail. So they need to go, for now, up here into the Hubflow. It's not something, because Workspace is a library, is a package, it provides services to others. It doesn't get to decide whether the process exits. Libraries shouldn't do that. When you see people putting hard asserts in libraries, slap them with that smelly wet trout in the best traditions of the internet. That's not the purpose of a library. A library can absolutely refuse to continue what it's doing and return an error back for the, say it's the caller's problem. Absolutely can. Nothing wrong with that. But it's not the place of a library to shut down your whole process and deep six it. Absolutely not. Right then. So let's go back. How long we got? We've been streaming for almost 2 hours 10 minutes, so we've got about 20 minutes before I want to wrap up. We've butchered well, I say butchered. We've got through Workspace. We've had a look at local and remote. And we haven't gutted them entirely yet. Let's look at repo. And nearly every operation we've got here belongs in our CQRS approach. So all branches, that's a query. So we're going to have that get all branches. Right. Sorry, this is going to be a bit slower because I don't have the physical space to have both panes open all the time. Package workspace, func, get all branches. And we are going to take a workspace for this, not a repo, workspace. Yeah, we're going to do that. I'm okay with that. Now we want all tags. So I'm hesitating here because I may actually be creating work for myself by doing this. In the old shell code, all branches and all tags are built up from the local branches and the remote branches, and the local tags and the remote tags. So if we strip this out of repo, I am just wondering whether that's sensible or not. I think it is, because what we can do, is our workspace now needs a parameter, some data in it. And one of the pieces of data we need is to know what the name of our remote is called. So that when you call all branches, let's open that code back up. So get all branches. The code for that's going to look something like this. And this is just example. We may not actually go with this. So I'm definitely going to be using some non-Golang syntax at this point. So we do local branches, w.local.get branches. We'll do something like that, and then we do remote branches, w.remote.get branches. And if we had a spread operator, we would simply do local branches, remote branches. In many languages, we would just use a spread operator like that. Sorry, let me make some space here. That's what we would do to unpack them and just return them. Now, Golang, clearly I'm doing that wrong, so I'm gonna have to look up the syntax to make that work. But that's how we would implement it. So at this point, what we're saying is our workspace has a local and a remote component that we can query and get at. I've got them as methods at the minute. That may not be the most accurate in the world, but that's the idea of the kind of code we could write. Get the idea, hopefully. So that means we are saying here workspace local returns a local and TBD, and we're saying we've got a func on Workspace, a method called remote, returns a remote, and this would be, so one of the interesting things about this is, hang on a moment, bear with me. Before I say that, let me write the code. So get remote w star workspace remote name string. So in theory we can do return get remote w dot remote name. In theory we can do that, and get remote can do whatever it needs to do. In theory we can write that code. So because get remote starts with a lowercase letter, it's not exported outside the package. But because it's inside the package, in theory, it can access properties of the struct that are not exported. In theory, I haven't actually proven that with this code, so yeah, we'll have to see with that. But that's the idea. We can do things like that, which also means w star workspace, we can do get remote name, return get remote w and remote name. So we can start to do things like that. We can start to build these public methods out that call into non-exported functions, so we can dry the code out a little bit, is the idea there. That's the idea. And then we'd go through and get rid of, and do all these. So create branch, something for us to look at. Got diff branches, find merge base, pull and rebase, push tags, create head, prune. These are all going to become part of our CQRS architecture. That's what they're going to do. But how are we doing against our objectives for tonight? If I go back to slide cam and actually go back to our objectives, we had 3 objectives for tonight. The first one was create the workspace structures plural. We're starting to get there. We're starting to find some shapes. Not yet sure these are the right shapes, but we're starting to find them. Building out a list of interfaces. No, we're not there at all on that tonight. If I go back to Linux Cam for a moment, because we don't yet know our structures, I'm going to go collapse this down to one workspace. That's better, one pane now. Because we don't yet know our structures, we know we're going to have something called local, and we're going to have something called remote, and that's going to hang things off. But we don't yet know what operations these are going to support. We're not there yet. I've got some ideas, but we're not there yet. This is the problem with abstractions. But we've got our workspace, and that is starting to take shape. Although I don't think we're going to embed the repo in it anymore. And of course, let's not forget, we've also got repo, which got closed when I closed that that second panel down. And yet we haven't yet finished pruning repo for the set of operations we want. So repo itself may not survive its current form. If we go back to slide cam, There we go. So in terms of building out the list of interfaces, we're not there yet. We need longer. We haven't found our abstractions in a way that makes sense, and in a way that can hide Git itself. It feels to me that both local and remote are going to end up becoming on the other side of our glass wall. So if I go back to iPad cam. So we've got this dividing line down the middle. This line here. This is our glass wall. And I suspect local and remote are going to move over here and be part of our Git abstraction layer. I mean, after all, if we look at the diagram a bit more closely, we can see here that we've actually talked about local and remote as two concepts and as part of the plumbing. So, and exploring it with code, it's starting to, although I've been gutting local and remote at the minute, at some point we've got to start adding in all the low-level operations, the plumbing that supports what the workspaces are doing and what our CQRS over here is going to be doing. So I think it makes sense really for local and remote to be what we export across our glass wall. It's starting to feel like that's the pattern we're going to do, which is quite neat actually, from my perspective, because it means this diagram's really holding up a lot better than is typical, to be honest. So yeah, if we go back to slides once more, there we go. Put the pen down, Stu. Right, and use the right mouse pad trackpad. We haven't yet identified the operations for our Git abstraction layer, but as we've just discussed, we really are getting to the point where local and remote are starting to solidify as the concepts. Even though in code terms, remote and local I've largely been deleting from, we're going to start having to put low-level operations in here. Now whether those are methods on those structs, or whether they are functions that stand alone, I'm not sure of. I think they're going to be methods. We can't use interfaces without that, and some of the business logic we've identified, like branch exists, for example, it shouldn't care whether that's local or remote. It shouldn't care, for example. So I think I'm answering my own question there, that we are going to have to build methods on those two structures and then come up with a set of interfaces to describe them. Back to slide cam. So yeah, so that's where we are at the minute. How do I feel about all this? Well, I have kind of got a hall of mirrors on my on that monitor over there. There we go. That's better. You can't see that, but it was like really distracting to the corner of my eye. So how do I feel about all this? I'm feeling okay about it. We've already done a couple of iterations tonight, even though there's no code committed. We started off by going through our high-level list of Git operations. We dumped them into. We tried to split them out between Workspace and Repo. As we were doing that, local and remote in terms of pure code emerged. So we moved things around into there. So that was arguably iteration number 2 or 3. And then I started to gut those and turn those into our CQRS operations. But they're operations being exported by the Workspace package. And that is a little different to our diagram. I'm going to go back to the diagram once more, if I can get the iPad to wake up. Come on, iPad. Yeah, one moment. There we go. This iPad's ready for replacement. Touchscreen's playing up a bit. So originally, I was looking at CQRS style here as being very, very close to the CLI. But really what we're talking about is the workspaces and Hubflow common kind of merging. Let me highlight that a bit better. So instead of workspace just being a structure and Hubflow common calling into it, we've kind of got this here is all in one now. It's going to, our CQRS code here, which the CLI is going to call, is going to be talking to other CQRS code. It's not, the workspace is almost a data bag that's being passed around rather than something that you perform operations on. Is really where we've gone with that. Not the end of the world. Not the end of the world by any means. So I'm feeling okay. I'm feeling okay about it. All right. And I'm slumping in my chair. I always do that. So we're coming up now to the end of tonight's live stream. We're almost at 2.5 hours, which is fortuitous. I didn't plan that. What are we going to do next week? I think next week it'd be nice to have some code compiling and running. So I think next week what we're going to do, we're going to focus on the local and remote structures and the interfaces, a lot more detail, and see if we can start to build out what the low-level commands would look like. I think that's what I want to do. And I'm hesitating slightly because there is an argument that we should continue on the left side of the architecture and build out more of the Hubflow stuff, the Hubflow CQRS operations, and maybe actually take one of the commands like init, for example, and actually build that out all the way through. So there's an argument there as well. I'm not sure. That's what I'm going to have to sleep on. In some ways, so pros and cons very quickly. Building from the CLI all the way across the architecture and back has the advantage that we're starting with our outcomes. Our outcomes, there's libraries there to serve the CLI and our API when we build it. So using the CLI to shape it isn't a bad idea. Because one of the things we want to do is we want to be quite minimalistic in our approach. We don't want to create functionality that we don't need. We haven't got time for it. I can't build out a full Git abstraction that does everything that Git can do. What I need is an abstraction that we can take our existing Hubflow operations, which we've previously identified. I need an abstraction that I can put those Hubflow operations into and be confident as we discover things that I've missed in my initial analysis from a few live streams ago. As circumstances change and we come up with new ideas we want to implement, we need to be confident our abstraction will accommodate those without too much or any rework. That's what we want to avoid. So going left to right kind of works with that. The reason I'm not sure about that, and the reason I originally wanted to focus on local and remote, is our code probably isn't going to compile until local and remote actually are more than just empty placeholders or emptier placeholders. And if the code doesn't compile, we're going to be very limited in what progress we can make from a practical point of view, because we can't test the bloody stuff. So we've got options there. So here's what we'll do. If you're watching this live, first of all, thank you very much. If you're watching this on catch up, please leave a comment on the video to say which you'd prefer for next week. Do you want to start from the CLI and work across and I work it all the way through, and we'll just tidy up the current code as we go through it and try and get it compiling and see if we can get feature init working. We'll see what progress we can make on that. Not feature init, Git Hubflow init, Git HF init. Yes, let's pick a sensible one to start with. So that's our option A, Git HF init. Do we try and get that working next week? Or do we focus on local and remote and really try and get the shape of those right and start identifying some of these interfaces? Leave a comment, let me know. And then Saturday morning, I'll go through whatever comments have been left and I'll announce the next live stream on Twitter then. All right. As always, thank you for watching. If you've made it this far, please leave a like. It helps people. Engagement with comments and likes and subscriptions is the YouTube algorithm, and it helps us find a larger audience. So it really helps us out if you leave a like, if you leave a comment, if you subscribe. Please tell people about this. I'm crap at marketing and sales. So if you're enjoying this, please tell other people about these live streams and encourage them to come and watch them. Thank you very much. I'll see you next week.